Supplemental math videos from Circle Christian School. Exponential functions. Oh, how appropriate they are for this season of the year. Just think about zombies and what happens with zombies. You get one zombie which bites two more zombies, which those two bite two more zombies. Oh my. Pretty soon we're just all going to be zombies. Parent function of an exponential equation is denoted by y equals a to the power of x, where basically the x is the variable that's happening here. Now, generally we couldn't have that y to any power here would result in any type of exponential thing because the result would always be 1, so it'd be rather linear. So generally we start with y equals 2 to the power of x, which once you put it into some sort of table here, that with the x and the y, that 2 to the power of 0 would hit the y-axis at 1, which is why generally it sits right there at 1. Giving it some sort of negative value just means that it's going to go in a negative way here. Okay, let me erase these guys. There we go. And we can pretty much tell where an exponential function is going to be hanging out at, because this is going to be the h up here in the power, and anything else being added and subtracted is going to be the k. So this h here is going to tell us if it's going to go to the left or to the right. Remember, the sign's going to show an opposite type of value here, and the k is going to tell us if the function's going to go up and down. And naturally, if it has some sort of negative in front of it, then it's just going to go the other direction. Now, this particular equation leads us to a rather famous exponential function known as the natural exponential function of e. And as you put different values in, we can start with 1, then we can try 3, 5, and work off to 10, that no matter what you do, the number approaches 2.178 and so forth and so on. So therefore E equals in nature 2.178. Think about those rabbits that exponentially multiply. I always think of the Visa commercial with that. So if you want to give me the values for what it is at 1, 3, 5, and 10 here, just use your calculator. Be very careful about how you put it into your calculator, remembering that the fraction should be in parentheses also. That if you want to give me those values, I'll give you cool little star points for it. Let's do a little bit of some exponential fun, especially with money. The big thing here when dealing with these type of problems is to really identify the parts of a problem. So for instance, principal in the very first one here is going to be the $9,000. The rate, generally some sort of percent, in this case it's 2.5%, and for our calculator use, we have to remember to change it into a decimal, so 0.25. Number of compoundings is just going to be 1. And then our time, that's years, is 5. So we throw it into the formula here to get the amount. Here's our $9,000, 1 plus the 0.025 over 1. And then 1 times the 5 is 5. And when you get done with your calculator, you'll find out that you have now $10,182.67. Nice enough. The deal here is it's using the formula is a little bit easier than using the simple interest formula of principal times rate times time equals simple interest, because then you'd have to do the first year, what you end up with that amount, then do it again the second year, third year, and so forth. Exponentially, it's a little bit easier. Next one, we have some variations inside here. So we have $12,000 now. Aren't you rich? Rate of 3%, so 0.03. Number of compoundings, the first time is going to be quarterly, so it's going to happen 4 times. And the years is 4 years. So we have the amount, $12,000. And 1 plus the rate over the number of times, which is 4. And 4 times the number of years, which is going to be 4. And once you get done with your calculator, you just have to kind of watch what is happening here. Try to do some things a little bit separately. If, for instance, you're doing the 1 plus the 0.03 over the 4 in your calculator, it's just good to always have your fractions in some sort of decimal form. And our final amount is going to be $13,000, 523, and I believe it's 91 cents. Let me check. Yes, very good. For the continuous one, we're just going to use the famous PERT formula. They call it PERT. And now what we have is the $12,000 E, and your calculators do have that little magical E button on it. In fact, it looks like E with a little X here, and the X is where you're going to put the R, which is the 0.03, and the T, which is going to be times the 4 here inside of it. And notice the difference in the amount when something is done continuously. We have $13,000, 529, a whole $6 more and 96 cents after 4 years. It'd be fun to try it and see what it would be after 10 years, just to see how rich you'd be. And give me that amount and you get some more stars also. The next one is going to be some radioactive decay. So now we're going to use a little bit more of a radioactive decay type of formula. Fortunately, they happen to give it to us. And y equals the 10. And 1/2 is our half life years. You can use 1/2 or you can use 0.5, whichever is easiest for you. And time over 29. So time over the 29 years here. So the first thing is to figure it with as it is when t is 0. So that's just going to be the 10 times the 0.5. to the power of 0, which means that's of course going to equal 1, so the whole thing's going to equal 10. And then to do it after 80 years, what it would be after 80 years. So we have the 80 over the 29, which it's helpful to actually put it into your calculator using the parentheses, the little power key, and since the fraction, the power here is some sort of fraction, make sure you put that into some sort of parentheses for your power also, to find out that it would end up being approximately 1.48. Now, because this is in a form of y equals here, it's particularly handy to go ahead and put it into your calculator and use your table function to find out what it is after so many years.